All right, so this video is going to go over section 2.0, examples 4, 5, and 6. It starts on page 5 in the notes. So for these examples, we're going to factor quadratic trinomials where we have an a value that is greater than 1. But since we're still factoring, we're going to follow our basic rules where the first thing we're always going to do is look for a GCF. Okay, so whenever you're asked to factor a polynomial, first thing you got to do we have a GCF? Second thing is if we have 3 terms, we are just going to reverse FOIL. Okay, so it's the exact opposite of FOILing when we have 3 terms. And then if that is not the case, the third thing we're going to do is look for a special case, which we will get into a little more as the class progresses. Okay, but you always want to follow those 3 steps when we're factoring. So going back to example 4, the first one that we have here, we have 3p squared minus 2p minus 5, and they're asking us to factor it. So the first thing I do we have a GCF? I look through it. You got 3p squared, 2p, 5. They don't have any common factors, so we do not have a GCF. Second step, how many terms do I have? I have 3 terms, so we're going to reverse FOIL. So I'm going to set that up to start. So I'm going to have 2 sets of parentheses here. Okay, for FOILing, we know our first terms have to multiply together to give us 3p squared. So the only way that would work out would be if I have 3p and p. From here, we have to find our second terms. So to multiply to get -5, I need one, my parentheses to be negative, the other to be positive. The only way we can get to 5 would be with factors of 5 and 1. Okay, so from here, I'm going to guess and check. Okay, I'm going to go ahead and try putting in a -5 right here in my first parenthesis and a +1 in the second. And then what you're going to have to do is FOIL it out and check your work. So FOILing, first, 3p times p is going to give me 3p squared. Out, going to give me 3p. In, minus 5p. And then my last, minus 5. When you go ahead and combine your like terms here, it's going to work out to where we have the original trinomial. So 3p squared minus 2p minus 5. It worked out. So there's our factored form right there. For number 2, we're going to do the same exact thing. Okay, so do I have a GCF? Absolutely not. 3 terms, reverse FOIL. So I set up my 2 sets of parentheses. Only way we can get to 3 would be 3 and 1. So I have 3n and then 1n. For this one, notice we have a +4 for the n term, and then we have a negative in the middle. Whenever you have a positive on the end, a negative in the middle, both of these parentheses are going to have negative factors. From there, once again, I'm going to guess and check. So I got to figure, okay, what multiplies to give me 4? We can either go with 1 and 4, or we can go with 2 and 2. I'm going to try 2 and 2. Okay? So that's my proposed answer. What you need to do, check your work. You go ahead, FOIL it out. You got 3n squared minus 6n minus 2n plus 4. When you combine your like terms, it's going to work out to where it matches up with the original. So we're good to go. There's our solution. Done. Okay, I got one more I'm going to do for you. You look at number 3, 6x squared plus 37x plus 6. No GCF, 3 terms. Let's reverse FOIL. So 2 sets of parentheses, 1, 2. And I got to think, okay, what multiplies to give me 6x squared? So factors of 6, you got 1 and 6, 2 and 3. You can try whatever you want. I'm going to go with 6x and x. I look at my signs. I have a positive on the end. I have a positive in the middle. So both my factors are going to be positive. And then when I look at this, my middle term has to get to 37. So that's a pretty big number. Okay? So instead of like doing 3 and 2 or whatever it may be for my factors of 6, I know I want to multiply that 6x by a 6. Okay? From here, go ahead and check your work by FOILing. You get 6x squared plus 36x plus x plus 6. It all worked out. We're good to go. That's my answer. Okay? All right, so I want you to try number 4 on your own, and then we will go over that solution when we go live. All right, example 5, completely factor. So they're going to give you a bunch of different polynomials here. They want you to factor it to the fullest extent possible. So we're going to follow the same rules we talked about in example 4. First step, do I have a GCF? So looking at example 1, we have a GCF. We have a common factor. 4 and 16 have 4 in common. Then I have m cubed and m. I can go ahead and pull an m out front. When I do that, I'm going to be left with m squared minus 4. Okay, so that's a good first step. From there, we have to ask ourselves, are we done? Look at m squared minus 4. We're going to get into this a little bit in example 6, but I can actually factor that m squared minus 4 down into an m plus 4. Sorry, not m plus 4. M plus 2, m minus 2. Okay, so that broke down the m squared minus 4. And then I need to drop the 4m down out front. So that would be the fully factored form. For number 2, same deal. Do I have a GCF? 16 and 2, yes, they have 2 in common. Not only do they have a 2, they have a negative 2. Okay, so we go ahead and pull our negative 2 out front. P cubed and P are going to have a P in common. And then that's going to leave me with 8P squared plus 1. Once again, you can check your work by multiplying it back out. So just distribute the negative 2P back in. Works out where it matches up with what we had up top. Okay, and then number 3 for this one, GCF. We do have a GCF here. So 4, 8, we're going to have 4 in common. Then I have z cubed, z squared, and a z. So I can pull a z all the way out front. What that is going to leave me with is going to be z squared minus z minus 2. Okay, and then just like we did for number 1, up here, we have to make sure we factor this down to the fullest extent. So I need to break this down into a z minus 2, z plus 1, and then drop the 4z down. Okay, just like we did for example 4, I want you to try the highlighted one on your own, and then we'll go over that solution when we go live. The last example I'm going to do for this particular video is going to be example 6. And example 6 is one of our special cases. So we want to be able to recognize and use the difference of 2 squares. Dead giveaway when you're going to have a difference of 2 squares is you're going to have 2 terms going on. Okay, that's the only time it's going to happen. And the general form we have for this would be if I have a squared minus b squared, that factored is going to turn into a plus b, a minus b. Okay? So when we factor, we're going to follow the same rules. Your first question is always, 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 do I have a GCF? Look at this first one right here. Do I have a GCF? No. Okay, so your next question, do I have 3 terms? No. So we're now down to our special case. When you have 2 terms, you are looking to see if you can fit it into this form right here, a squared minus b squared. So at this point, you have to ask yourself, what happens when I take the square root of x squared? What's the square root of x squared? It's going to be x. That goes in each set of parentheses out front for a. Last thing you got to do, what's the square root of 4? Square root of 4 is going to give you 2. So just following the form, I'm going to have a plus 2 in the first one, minus 2 in the second one. Okay? And then you can check your work by multiplying it back out. And you're going to end up with x squared minus 4. For number 2, same deal. Do I have a GCF? No. Do I have 3 terms? No. So I'm looking for a special case. Since we have 2 terms, we're going to try to fit it into our difference of squares. So you have to ask yourself, what is the square root of 9? Square root of 9 is going to be 3. What's the square root of v squared? V. So I'm going to have 3v showing up in each parenthesis. And then remember, the last thing you got to do, what's the square root of 1? Square root of 1 is going to be 1. So we have a plus 1, minus 1. That's it. And then the last one I'm going to do with you is going to be example 3. So looking at that, no GCF, I have 2 terms, so we're going to try to fit it into our difference of squares. Square root of 36 is 6. Square root of x to the 4 power is going to be x squared. That's going in each parenthesis. Last thing, square root of 49. Square root of 49 is going to be 7. I'm going to have a plus 7 minus 7. And that's it. So go ahead, try the highlighted one on your own. And like I did for examples 4 and 5, we will go over that at the start of class.